This video will cover heat of fusion and heat of vaporization. Now, heat of fusion is defined as the amount of heat needed to melt a solid to a liquid without a change in temperature. Heat of vaporization is the amount of heat required to change a mass of liquid at its boiling point into a vapor without an increase in the temperature. Now, temperature and pressure would both be constant. The symbol for heat of fusion is right here, and the symbol for heat of vaporization is right here. Both of these are sometimes called latent heats. Now, for heat of fusion, the equation we use is Q, which stands for the heat energy, will equal the mass times the heat of fusion. For our heat of vaporization, we have Q, again, which is our heat energy, equals our mass times our change in vapor heat. And so we're going to look at some of these problems in our upcoming slides. Now, before we look at the upcoming problems, I wanted to show you this chart of heat of fusion and heat of vaporization. You'll notice that we have our substances over here on the left. You'll notice that each substance has a specific melting point. Each substance has a specific boiling point. Also, each substance has a specific heat of fusion, whether it's going to be kilocalories per kilogram or kilojoules per kilogram. Likewise, each substance has its set heat of vaporization, either kilocalories per kilogram or kilojoules per kilogram. So as we look at these problems, you will see that when we talk about heat of fusion and heat of vaporization, I pull these numbers off of a chart and they are set constant numbers. As we begin looking at our heat of fusion and our heat of vaporization problems, just remember our definition that during the phase change, the temperature will remain the same, but the energy that's added to the system is what is used to change from one phase to the next. Also, if you will remember from our previous slides, here we have our heat of fusion, where we have our heat equals our mass times our heat of fusion. And here we have our formula for heat of vaporization, where our heat energy equals our mass times our heat of vaporization. Now, these numbers right here are numbers that would be pulled off of a chart. If you look at our previous chart, you're going to notice that these right here were rounded up a bit just for convenience. It is better not to round the numbers, but to actually use what is stated on a chart. But we're going to use these on these problems. Now, our first problem says how many joules of heat are necessary to melt 500 grams of ice at its freezing point. Now, we're going to have our heat, which is Q, equal our mass, which is 500 grams, times our heat of fusion. And what we're going to notice is that our grams cancel out, and so we would have this in joules, and because we want to know in kilojoules, we would have 170 kilojoules. In our next problem, if we have our kilojoules, if we have our joules of heat given, and we are talking about steam condensing, we know that we're dealing with vaporization, and we want to know what is the mass of the steam. Now, do remember that steam is water, so we're going to be using our heat of vaporization equation, where we take our heat energy will equal our mass, which is X, times our heat of vaporization, which was stated as a standard. We're going to solve for X, and we would have 25 joules over joules per gram. Joules cancel, 25 grams. And let's just go over a few other problems. I did put the equation to the side, and I gave us our heat of fusion and our heat of vaporization for water. These are going to be in calories per gram as opposed to joules or kilojoules per gram. Here we have how much energy is required to melt 100 grams of ice. And so what we're going to do is we're going to use our heat of fusion right here. We're going to take 100 grams times our 79 calories per gram from our heat of fusion. Grams cancel, and we would get our answer in calories as 7,900 calories. How much energy is required to vaporize 234.5 grams of water? So we're going to use our heat of vaporization equation. So we're going to have Q, our heat energy, equals our mass, times our heat of vaporization. That was our standard. Notice again that our grams cancel, and we would have an answer right here of 1.27 times 10 to the 4th calories, or about 1,270 calories if I move my decimals over correctly. Okay, on this last equation we have if 30.6 calories are required to vaporize 25 grams of a substance, what is the heat of vaporization of that substance? Now we need to fix this right here. It's my boo-boo. And so we're going to start off by using the heat of vaporization equation. And so we're going to have our 30.6 calories equaling 25 grams times x. We will be solving for x. So x would equal our 30.6 calories divided by 25 grams. Our answer will be in calories per gram. We do the math and we would get 1.2 calories per gram.